Good morning, everyone. Myself, Sanjay Ugare, Assistant Professor at KLE College of Pharmacy, Belagavi. Today, we are going to discuss on the topic of the neurohumoral transmissions. Okay, the name only indicates the neurohumoral transmission. It is the transmit of the message or neurotransmitter from the one neuron to the another neurons. Now, we are going to discuss on the again what are the steps are involved in the neurohumoral transmissions. Usually, already definition we discuss, it is the transmit of the message from the one neuron to the another neurons. Usually, there are different steps are involved in the transmission of the impulses from the one neuron to the another neurons. First, the impulse conduction it is the conduction of the impulses. Okay, the resting usually whenever you want to transmit a message from the one neuron to the another neurons, first the what are the impulses are there in the bodies. If you take any organs of, usually the conduction of the impulses usually takes place. Okay, usually whenever you take any membrane of any organs, like you take heart, liver or kidney, any organ you take any membrane, usually whenever the membrane is at the resting condition is always at the minus 70 megawatts. Okay, whenever you take normal membrane, the membrane is at the resting stage, means it is always at the negative side. Okay, it is minus 70 megawatt. Okay, whenever the impulses start conducting in our bodies, whenever what are the impulses are there, they start conducting in the bodies. Usually there will be a again there is stimulation of this membrane usually takes place. Okay, the resting task membrane is established by the high potassium permeabilities. I told whenever the membrane is at the resting stage is minus 70 megawatt. It is minus 70 megawatt means inside you are having a lot of potassium ions are there, and outside the membrane you have a lot of the cations are there. Okay, like sodium or calcium, and inside the membrane you have a lot of the anions are there, like potassiums and chloride ions. Okay, whenever the impulses are there start conducting in the bodies at the normal levels only, there will be conduction of the impulses, then the generation of the impulses, then transmit of the impulses. These are the steps usually taking place in the neurohumoral transmissions. Okay, whenever the there is again impulses start conducting, then this membranes get what you have a lot of channels are also there in the membrane, lot like sodium channels, potassium channels. These channels get opened. Okay, whenever the impulse start conducting, then there will be influx and efflux of these cations as well as the anions usually taking place in the bodies. Okay, and stimulation, if you stimulated the membranes, or stimulation or arrival of the electrical impulses causes a sudden increase in the sodium conductions. Okay, when you stimulated this membrane, there will be conductance of the sodium ions. Okay, what are the sodium ions? Like cations, usually they are present outside the membrane, they get deposited inside the membrane or influx inside the membrane. Then usually you're getting the effect, usually depolarization effect, that is contraction of the membrane usually taking place. Then whenever the membrane get contracted, then you already know it is the next normal stage or resting stage, it is 70 megawatt negative side. Then whenever stimulation is there or contraction of the membrane is there, then usually this sodium ions get deposited or influx inside the membrane, then it get converted into the minus 70 megawatt is get converted into the plus side, that is 20 megawatt is converted becoming a 20 megawatt positive sides. Okay, then if more cations like sodium or calcium get influx inside the membrane, then it is what are the potassium ions are there, that is anions are there, they get efflux from the membrane, go out from the membranes. Okay, then move out in the direction of their concentration gradient, then usually the membrane get contracted, then it become positive over nature. Then finally the ionic distribution is normalized during the refractive period by the activation of the sodium potassium pump. These are the pumps or channels usually present on the membranes. Okay, whenever you stimulated or a membrane get contracted, then the sodium ion get influx inside the membrane, then depolarization effect, that is contraction effect, usually get inside the membrane, then potassium ions move out from the membrane through the potassium channels. you have sodium channels or potassium channel, calcium channels. Sodium channels is only sodium ions movement will be there. Potassium ions, potassium channels are there. Only the movement of the potassium ions will be there. Okay. Then then again next steps will then the action potential thus generated. Set up a local means action potential means the movement of the ions will be get started. Then the local circuit current which activates the ionic channels at the next excitable part of the membranes. Once the membrane is get activated, then there will be transmit this process will be continued at the next part of the membranes. Okay. Then after the conduction, then there will be transmit of the impulses. Okay, you should transmit that impulses. Once it is generated, you should start that or you should transmit that impulses to the next part of the bodies. Okay. What are the transmitters? You have enzymes are there, you have proteins are there. These are called transmitters. They get transmitted from the one part of the another part of the bodies. Okay. Usually the transmitters store in the pre-junctional nerve ending within the synaptic vesicles. These are the what are the transmitters are there, like you have enzymes, proteins. They are usually stored in the presynaptic vesicles. Okay. Then the nerve impulses. What are the nerve impulses are there, which promotes the fusion of the vesicular and axonal membrane through the calcium entries. Then all the contents of the vesicles, usually you have contents means you have already told transmitters, enzymes, and other proteins. These are called as the usually transmitters. Usually they are stored in the vesicle. Then they are extruded in the junctional clefts. Okay. Then the release process can be modulated by the transmitter itself and by the other agents. Okay. What are the transmitters or enzymes that are stored in the pre-junctional state? They get released. They are stored, then get released in the release from the bodies. Okay. The release process again they can be modulated by the same transmitter itself only, or by the other agent through the activation of the. Once they are stored, they should be released from the pre-junctional site through the activation of the membrane. Okay, what are the membrane is there? If they get activated, then these transmitter get released from the pre-junctional site by the activation of the specific receptors. Okay, then what are the transmitters are there, or what are the enzymes are there, and what are the proteins are there? They are stored in the vesicle, but after the activation of the membrane, they get released from the pre-junctional site. And after releasing, they act on the particular receptors in the bodies or particular site in the bodies. Okay, they want to show the effect in the bodies. Okay, then this transmitter usually act on the again post-junctional membrane. They stored in the pre-junctional site. After releasing, they act on the post-junctional membranes. Okay, the release transmitters again. What are the transmitters are there? They combine with the specific receptor on the post-junctional membranes. Okay, these. What are the release transmitters are there? They act on the again specific receptor on the post-junctional membrane. Depending on its again, what are the nature of the transmitter? Either maybe it is an excitatory in nature or inhibitory in nature. What are the transmitters are there or enzymes are there? Maybe they are excitatory. You want to show the excitatory effect, or you want to show the inhibitory effect. Suppose if the heart is not working, heartbeat is heartbeat is very slow. You want to make the excitation of the cardiovascular membranes, or you want to increase the heart rate. Then you are giving the that is excitatory neurotransmitter. You want to make the or decrease the heartbeat. You are giving the inhibitory. You want to show the inhibitory neurotransmitter or transmitter in the injecting into the bodies. Okay, these are normally taking place. That is excitation effect or relaxation effect. But in some of the pathophysiological conditions, there may be improper contraction or improper relaxation of the cardiovascular system or any part of the bodies. In that condition, you are giving the excitatory neurotransmitters or inhibitory neurotransmitters. They are available especially in the market. Okay, suppose if you take the adrenaline is the again neurotransmitter. It is naturally secreted in the body. It's showing the excitatory effect on the cardiovascular system. But if we want to, if the heart is not working properly, it is not contracting properly, then you are injected external neurotransmitters that will be act on the post-junctional receptors and or post-junctional membrane, that's showing the contraction effect. Like this, the effect usually normally taking place in the bodies, but in case of the pathological conditions, if this effect are not usually taking place, in that conditions you are giving the external hormones. Then this transmotors or transmitter then act on the post-junctional membrane. They show the again excitatory effect or inhibitory effect. That is excitatory post-synaptic potential and it or inhibitory postsynaptic potential, because they acting on the post junctional side. That's why your effect is excitatory postsynaptic potential or inhibitory postsynaptic potentials. What are the things usually happens in the excitatory postsynaptic potentials? Increases in the permeability of all the cations. Usually excitatory effect usually getting whenever the I told the cations are usually present outside the membrane. Then these cations get influx inside the membrane. Then usually getting the excitation effect, like calcium ion influx through the fast or slow channels causes the depolarizations, followed by the whenever the cations get influx, then anions usually obviously should get efflux from the bodies. Okay, then followed by the potassium efflux. Then the ionic movement are passive in nature, as the flow is down the concentration gradient. Like that, you are also getting the inhibitory postsynaptic potentials. And what are the things? Usually in case of the increase in inhibitory postsynaptic potential, increase in the permeability of the smaller ions, that is potassium ions and chloride ions, so that the potassium ions move out in the direction of the concentration gradient, and chloride ions also move. Then you are getting the relaxation effect in the bodies. Okay, usually in case of the relaxations, more potassium ions move out from the membrane or efflux from the membrane. In case of the depolarization effect, more cation ions get influx inside the membranes. Then after showing the effect in the bodies, then you should want terminate the effects in case of the more excitation is there in the bodies, or in case of the lower inhibitory effect in the bodies. You want to make the termination of effect this in the bodies. Then you also some drugs are also available in the market. That can be hormones or drugs that terminate the effect in the bodies. Okay, usually you want to make termination means you should degrade the effect of the what are the drugs you have injected, or showing the more excitation effect or low inhibitor. Simple concept is that you should degrade the net effects. Okay, following its a combination with the receptor. Degradation means again the antagonist, your antagonist should be injected. They act on the same receptor, then block that agonist drugs, then usually degrade in the body. These are naturally happening in the bodies. If it is a natural, in case of the pathological conditions, then you are injected the external hormones. Okay, following in its combination with the receptor, the transmitter is either locally degraded, is taken back into the pre-junctional side. What are the post-junctional effects you getting? Then you want to make local, in case of local degradation, again go into the pre-junctional neuron by active uptake diffuse pathways. Again, example is one example is then noradrenaline specific carrier protein like norepinephrine transporters, then dopamine transporters, then serotonin transporters are the expressed on the axonal membrane of this purpose. The rate of the termination of the transmitter action goes the rate at which the response can be transmitted across the junctions. Okay, these are the concept is same here. The termination of the transmitter effect. Whenever the more effect is getting, you want to make the termination, you should use the antagonist again that will be terminated. That go and act on the same receptor, block the agonist effect. Okay, these are normally happening in the bodies. Whenever the more contraction is there, then usually the one contracting drugs will be, contracting hormone will be there, one relaxing hormone usually secreted in the bodies. Whenever contracting hormone more secreted, then obviously the relaxing hormone should stabilize the cyst and makes the local degradation in the bodies only. Okay, in case of this pathological condition not taking place properly, then you can inject the external hormone in the bodies. These are the concept of the neurohumoral transmissions. First, the release of the neurotransmitters, then conduction of the neurotransmitters, then after the conductions, then you should act on the particular receptor, either show the excitatory postsynaptic effect or inhibitory postsynaptic effect in the bodies. After that, then the termination of this neurotransmitter effect in the bodies. Okay, this is a concept regarding the neurohumoral transmissions. Thank you.